Say hi in the chat to everyone else, and we can get started. While you're saying hi, I'm gonna start sharing my screen. Hey, yeah, it's happening. Okay, so this is what my screen looks like. We're gonna talk about building our own DevTools. You can see me as Zbigniew Tenerowicz or Zbyszek Tenerowicz, depending on which part of the screen you're looking at. But my internet handle is Naukta. And if you type that into a browser anywhere, you're going to find everything I did, the proud moments and the otherwise as well. So I made sure this is pretty unique. If you want to follow along, that's also what you're going to use to find the material. But let me get to that in a second. So we're going to talk about building your own developer tools. Oh, give me a second. I need to change one thing. Okay. That's a lot of highs. Cool. I'm back. So the obvious question: why? Why do that? Well, you could build your own tools, but there's diagnostics tools already. And we only have a bit more than an hour. So what's the point? Well, the point is this is a fun example. So building developer tools is always fun. And the goal here is not to build an actual developer tool that's ready for business. The goal here is for you to learn about some hidden gems in Node.js, some lower level APIs. And I hope you're going to like them. And maybe at some point, they will actually help you diagnose something or build some diagnostics into some of your applications. But the goal here, I want to be clear, is nerdy entertainment with a chance of learning. Okay, so let's mention some real tools. So there's developer tools that you can actually connect to Node.js with the inspect flag and opening Chrome DevTools and then switching to the Node part of them. And there's profiling and everything. That's very useful. Some of those tools are indispensable. So make sure you learn a bit about them. Today is not about those. There's also Clinic.js, which is a very nice tool. It does some of the things that we're going to do here, but in a much more polished way. It's much more helpful. At the same time, it's fun to build competition to such a good product by just writing 100 lines of code in an hour. So with that, let's go into some explanations. So this is the short part where I'm going to tell you about things instead of showing you things. I hope that's going to finish soon. But we need to do a bit of an introduction. First, event loop. Well, I hope you paid attention to the talks on Monday. But in case you didn't, or you need a bit of a refresh, I'm going to tell you what the event loop does, okay? Click a no if you think I should skip that. I'm going to give you 10 seconds. Well, no one's really opposed to that. So let's go into the event loop. Okay, so I have this Blackboard here. And what we know about event loop is that this is how Node.js works. So there's a loop going on, running in circles, okay? And there's a bunch of things scheduled, and whenever the loop reaches that point, it takes one item from the queue. And then for actual input output or doing any heavy lifting, we have the threads. So the loop takes your function from the top of the queue, runs some JavaScript. So this here is JavaScript statements, JS. Okay, and then at some point of your JavaScript function, you do something asynchronous. So like make a database request, and that gets put onto one of the threads here. Okay, so we have a bunch of threads. Actually, it's 5 by default, as far as I remember. And one of the threads gets the work, and when the work is done, it schedules running your callback with the result. And then the event loop continues, and if it happens to be the time to reach for your callback, it's getting the callback, pushing the result in, and it continues to run. So if your JavaScript happens to be taking too much time, the whole process stops at this JavaScript. And that's called blocking the event loop. I hope my scribbles were useful. Oh, hello. Someone's joining. Okay. So to the people who just joined, hello. I just finished scribbling on a blackboard explaining the event loop. I hope you know that. We were talking about event loop. So this is a very crude text representation of what event loop does if this format is more approachable for someone. So it's an infinite loop of getting stuff from the queue, running it, and then it schedules work. And we can get events from the outside, like an HTTP request, and then callbacks get scheduled on the queue again. That's it. Moving on. It was obviously a huge simplification, but yeah, there were much better talks about event loop on Monday. Hope you saw them. We're going to focus on async hooks. So this is the main tool that we're going to use today in this workshop. I'm going to give you a hand-wavy explanation of what those hooks are. So let's start with the hooks themselves. So there's a hook called init, and that's running when an asynchronous resource is being created. So whenever we pass a function to a then, and there's promises involved, or there's async await, there is a resource created that represents the future result. And the init is called synchronously at the time when it's created. The important part is for this hook, you can read the stack trace, and it's going to contain steps leading to the point of creating this asynchronous resource. Now there's a promise resolve, which is the newest out of these hooks. It was introduced a bit later than everyone else. And this additionally covers situations where a promise got resolved without creating a specific async resource that had the before or after, etc. It's a bit complicated. I don't want to get in depth why this was created, and we're going to disregard it for now. It can be useful in some situations. Now there's before, which is called right before the function starts. So there's an asynchronous function that's queued somewhere, and when it's taken from the queue into the event loop before a hook is triggered, right before the code starts. Similarly with after, once your function returns, the after hook is called, and there's a destroy which gets called sometime after everything else finished. So when the whole asynchronous resource can be destroyed, the destroy hook is also called, and you can clean up stuff if you need to. Okay, so that's what it looks like. You require async hooks. You create a hook, pass the right functions. You don't need to pass all of them. And then you enable it. This is the important part. You need to enable the hook. You can enable, disable it at any time. So your application doesn't have to run with the hook enabled all the time. You can just switch it on or off whenever you need it. Okay, I hope that's clear. If you have any questions, please raise your hand or type in the chat, and I'm going to see you. Looking at the side screen, I think it's okay. Don't really measure the delay between me saying it and you hearing it, but it should be very short. No questions in chat. Moving on. Yeah, let's have some fun with async hooks. You should be seeing my code editor. I'm gonna check the font size. Yeah, you probably wouldn't mind if I zoomed it a bit in. Okay, so that's literally the thing I just had on the presentation. It takes async hooks, creates a hook, puts the after in it. So how do we use it? Well, we need to run this code alongside the code we want to measure. So we're going to need some examples of the code we want to measure, and they're in the sample folder. But before I go into that, you probably want to have a chance to get your copy of this. So let's look at the browser first. And you can go to nauctor.pl, and the first link there is workshop on diagnostics tools, freshly added here. So I'm going to leave it up for a second for you to see, and I'm also going to share this in the chat. Hello, chat. Sharing this. Okay. Oh, can I zoom? Yeah, so responding to the questions, yes, the recording is going to be published, and I'm going to zoom. I did zoom a bit more, so I hope this is enough. Let me know if this is enough. Okay, so what to expect? You open this debugging tools live coding repository, and there's a demo branch that has all the steps that I'm going to go through. Okay, so you can check it out. There's some tags, so be sure to check out the tags available on the repository. Tag 0 is the actual beginning, and then there's 2 tags about hooks that we're gonna use at some point. Okay, I can hide the chat now so that it doesn't obscure the rest. Let's look at the samples, specifically the minimal one. So this is a bit of code that's very dry. I have a promise all, which means the things in the ARI are going to run alongside each other. So I have one promise chain and then another promise chain, and there's one callback for this promise chain and then another callback. This one is a function that's going to block the event loop in a very naive way. So let's pretend this is doing something like counting huge numbers or parsing megabytes of JSON. But for our purpose is just taking time, burning the CPU cycles, making sure that it takes as long as specified. Okay? So this is how it's happening. And now let's look at the code. This is the live coding part, but no one likes to watch people type. So I'm not going to do the typing. I have an entire tool set here to skip over to the next step, and I'm going to do just that. So let's look at the highlights. VS Code is helpfully highlighting the stuff that just changed. So I pulled stuff from the next step. And so we need to put something in the after hook. So after everything that happens asynchronously, we're going to push the async ID of that thing into an array. And then after a second of running the whole thing, we're going to dump the array to the output. Let's take a look at it. Okay, so I'm going to run the example with just npm test. There's a test script that happens to run the example. So what it does is it runs Node. It requires the diagnostic tool that we just built. Ignore this part for a second. And then it's running the sample number 1. The slow function is printing the time it took. And then we're printing the array. So something worked. We have the async IDs of all the things that happened asynchronously over the entire script. Obviously, for a bigger application, there would be a lot. And one takeaway from the slow function is the console time. So if you didn't know, console time is the most basic tool for timing stuff if you're not running in production. There's obviously better ways to do it, and I'm going to show you those. Okay, moving on. So we have this diagnostic tool. It's very basic. So now let's figure out what more we can do with it, right? Switching to the next step, we obviously want some live output from whatever is happening in our process. And the simplest way to do it is to log to the console. Memorable moment. Don't do that. So see, something's wrong. We only had 7 hops before, and now we're running the same script and it keeps growing and growing, and I'm going to stop it before everything crashes. Thank you. What happened? Well, if you thought console log is not asynchronous, this is proof that's not true. So what do we do now? Well, this is the first lesson you learn when you attempt to use async hooks. No one's going to tell you that in a presentation, but for async hooks, you cannot use console log. There is a function called process._raw debug. This is underscored, so it could go away at any point. But it's been there for a while, and this is the way you print things out. And you can be certain that this is going to be printed asynchronously. So our funny little tool is now going to have an output. Let's try that again. And we're getting the async ID and a bit of text. So we know that we had 2 asynchronous things happening, and then the slow function, and then another slow function, and then a few more hops. Okay. By the way, the last one was probably the promise.all from the example. Okay. So far, so good. Let's see what else we can do, right? This isn't very useful for any sort of diagnostics. So let's take a look at this. We can store some information. And there's more information in the init hook. So I added the init hook. You can see it here. The input to it is async ID type trigger async ID. And there's one more, but I explicitly don't want to talk about it at this point. I might get back to it just to tell you not to use it. And now I'm creating a new map in the top scope to put stuff in it. So I'm going to use async ID to identify things because that's unique. And it's traveling with me to the after callback. So in the after callback, I can get this data from our map and print it out. Let's see a bit of output. So you can see now that there's the trigger async ID and async ID, and then the type. So trigger async ID is the ID of the asynchronous resource that was the one that made our current asynchronous resource happen. Okay, that's the trigger async ID. Hence the arrow. It's going from 2 to 3, and then 5 to 6, and then 3 to 4. See, these are in chronological order, so this is kind of interesting at this point. We will discover why these numbers aren't in order in just a moment. And you can see that the resource type is mostly promise because our example was mostly promises. I can run the second example and you'll see there's much more. Not going to show you the second example yet, but yeah, you can see there's TCP, tick, promise, some more TCP, some DNS resolution, interesting stuff. Okay, let's not get too far ahead of ourselves because this isn't a useful diagnostics tool yet. Next step. Well, as I said, the init hook is running in the context of current synchronous execution. That means you can capture a stack trace. So let's do just that. And one interesting bit of Node API is that you can take any object and call error.capture stack trace. And it's going to take the current stack trace and put it on that object as if it was an error being thrown. So you don't need to throw errors and then catch them to have a stack trace. There's this handy function to produce a stack trace and write it onto an object. And another bit of trivia, stack trace limit, very useful stuff. So some stack trace limit is set by default. You can change it for your application if you want. And the interesting bit is you can even set it to be infinite. So there's the JavaScript number called infinity, and you can assign that to this variable. It's also going to work. So any length of stack trace is going to be available to you. For our examples, 20 is enough, but we could go more than that, no problem. So here I'm putting the stack trace in the data and then printing it out. So this is the first time we're going to see something useful, although it's going to be a lot of text. So get ready. Yeah, I'm going to run the simple example and make sure it's readable. So there's a lot of stack traces now. I'm going to scroll up. See, so this obviously starts with an error, as every stack trace has to be an error stack trace. That's a funny quirk. Then it says it's coming from our tool, but then it jumps through all the internals for hooks. And here, this is an actual place in our application. So we know that something happened asynchronously that was defined in this particular line, and let's use that information. So this is, oh, someone's joining. Hello, Javier. You're a bit late. I'm not going to be able to introduce you to everything, but I hope you have fun. Okay, so a little bit of VS Code advertisement. You can control-click those links to get to the actual line. So we're seeing that the async resource number 3, triggered by async resource number 2, is in this line. And then the next one is here. So we got promise all, which starts with a synchronously resolve promise, and this is where another promise is created for the result of this function. Okay, going a bit further down, we're getting here. This is the slow function starting. Okay, and the slow function is taking some time. And the other slow function is happening. You can trace the whole thing. See, now the promise all is happening at the end because we're looking at the after. All right, that's nice. Let's do something even better. I'm going back here. Going forward. Okay, so the stack trace is not a very useful diagnostic output. We need to clean them up and filter those, etc. So the first thing we can do is make sure that the stack trace includes something that's going to mean it's familiar. So this is a very basic example, and the way to find out which stack traces are useful is not going to be that, but I just wanted to show you that at some point we need to start filtering by the stack trace content. So this here means if a stack trace is coming from your application or anywhere in the disk, not in the internals of Node.js itself, we want to have it, and otherwise we would ignore it. In our simple examples, this isn't going to be useful. So I'm going to skip over to a different solution to that problem. So instead of capturing the stack trace and printing the stack trace, we're going to capture the stack trace and turn it into what I called location. And getting the location is a bit of work. This is the simplest way possible. So first we're taking the stack trace, splitting it by new lines, which gives us frames of the stack trace. Frames mean the thing that you put on the stack. This is what they're called. And we're getting rid of the two items at the beginning. If you look at our previous output, the first item is the word error, very useful. Let's skip it. And then it's our current position in the diagnostic tool, also not useful. So we're getting rid of those before moving forward with the stack trace. And if you see everything else, it's internals, some wrappers, etc. And then the first useful information always starts with a slash in the bracket. Okay, so that's what we're gonna look for. So we're gonna go through frames and find the one that has this text. So dot includes on a string is just checking if the text is somewhere in that string. If we didn't identify any line like that, which is possible, we're going to return nothing and then not proceed to save anything. But if we did find something, it's going to be useful to put it in our data. And then in the after hook, we read the data, and if the data is there, we're going to print it out. So this output is going to be much more readable. Okay, this is our app, and it barely fits in the terminal. Let's hide this sidebar for now or something. Can I do that? Please let me do that. Okay. Yeah. So now we're looking at a much more comfortable, readable output. This is the first time this seems like a useful tool because it gives you one by one, every step of the way, which line was being run at this point in time. Well, I'm using the after hook. So the line gets printed after the function has finished. And as you can see, there's a console used, and this is also asynchronous. We're getting that. See, you can explore the whole history of asynchronous jumps of your application. So that's beginning to be a bit of a fun thing to do. Let's give it a bit more. Okay, even more improvement. What changed? The location function changed a bit. So we're still finding the frame that we identified as something coming from our code, but then it's not just our code. It can come from our dependencies. So our dependencies are going to be / node modules and so on. So we also want to know where in our code this thing is coming from, which means we need to find a way to identify our code. This can be done in various ways, and the basic way here that we're going to use, because our examples are just a single file, which makes it much more simpler, we can just grab the file path of the file being run from the process args and use that to find the right line. Okay, so if we didn't identify anything useful, we return no. If we identified something that's actually from our own code, we return just that. But otherwise, we return the thing we identified, and then further in the stack trace, where from our code was this coming from. Okay, let's look at this output. Didn't change, right? Because our example is too simple. So let's switch to example number 2. And now it's time to look at what's there. Okay. This is a fake application that's caching stuff in Redis. If you want to run it on your own, you're going to need Redis on a default port. Or if you have Docker and Docker Compose, you can just run this Docker Compose thing. When you want to fiddle with this, it's going to spin up Docker. I already have Redis running in Docker behind the scenes. So what this is doing, there's a function that's called work, which is going to do the work of reading a file, making sure that the data is cached, and then disconnect from Redis. So this is a very simple simulation, and we want to check if the thing is in Redis. If it's there, we want to parse the data, and the data is package.log.json. So there's some parsing involved. I hope we're going to see it in some graphs later. And then we also have a save function that if it wasn't cached, it's going to save it. Okay, and there is a key for the cache, which includes a random number. So I actually broke this implementation. It's caching every time because the key in the cache is not going to be there unless we're very unlucky. So if you want to play around with looking at the differences between this example, creating the cache and then not creating the cache, you can remove the random bit and compare how it behaves. Maybe if we have enough time for that, we can also explore that. It's going to be interesting, but let's consider that fun for later. Okay. Now to run it, we're going to need the second example. So it's the example of simple asynchronous stuff that's actually work, not just empty promises. I'm going to run that, still disregard the trace event categories part. I could remove it and nothing would happen. It's going to be useful later. But now the fun begins. Yeah, need a bit more room for that. Okay, it starts here. So we have the first step that's happening. It's at Redis set status. So I can control click, and it's going to open Redis implementation from my Node modules, and it's using some next tick magic. But this is coming from this line in our code. Redis, new Redis. So when we're creating a Redis instance of IORedis, this is what's happening behind the scenes. We can explore the whole thing. So there's a standalone connector happening, fun, and it's also happening after we just called this constructor. So these are the steps happening behind the scenes, and then once something starts happening, we have, for example, Redis send command, which is writing to a command and then pushing something in a queue, and a lot of magic is happening behind the scenes. It's a library, it's doing its stuff. And then I hope this is what I clicked. No, which one was it? Index.js 600 something. Okay, and it's coming from here. Okay, and the line is redis.get. So our line, redis.get, was in the stack trace for an asynchronous operation in Redis that happened here. At this point, we have something that I would consider useful, although it needs a lot of work to be useful on a real application that's doing real stuff, because you would get a lot of output out of this. So there's a lot of work to be done to make this production grade, or whatever you want to call it. But this is enough of a demo of having a tool that does something potentially useful, where you can explore what your application is doing. And it's very useful for experimentation. You can take a bit of code, put it in a file, run it with this on, and explore what's happening. It's a good learning tool as well. Okay, so how to play with it. If you have the repository, there's a tag called hooks early. This is the early version of what we're going to implement as the hooks tool. So we can check out this tag, and it's going to contain exactly this step of the way. So it's a shortcut to this point in our workshop, and you can take it, run it on the examples, and so on. So this is the moment where I would be open for questions. So if you have any questions, feel free to write them in the chat. I'm going to give you a few seconds to pop up the questions. A sip. Okay. Multi-process async hooks. Okay. So async hooks are a part of the event loop. So when you have multiple processes, each of those have a separate loop of their own. And that means you need to set up separate hooks for that. It works the same with threads. So if you listen to any of the presentations about threads in Node.js, worker threads to be specific, if you set up async hooks, they're not going to reach into the thread as well, because thread has a separate context, and the context for V8 contains a separate event loop of its own, or at least the hooks bindings. So you need to set it up yourself. I hope that answers the question. And then the other way around, if you set up hooks and you're getting too much information, the way to filter that is to look at the stack trace and make sure that it's relevant to you. So you need to find interesting bits in the stack traces and ignore everything else. Okay, moving on. So this is hardly everything we can do. There's much more. So I'm gonna move forward. Did I get updates to the file? Yeah. Okay, so new hooks. There's after that we've been using, and now I added before and promise resolve, just to show you what they're gonna look like now that we have a reasonable output. Okay. Again, need more room. Okay, so there's a promise resolve. It's coming from here. So we have this shortcut for creating a promise. There's no actual asynchronous step happening here, so there wasn't a before and after for this. And then the other one. So these two are happening right away. And then the next thing is a before on this one. Then a promise resolve on this one. So the promise gets resolved by the function returning result. And after the function returns result, there's the after callback for the same line. So there's 3 of them. And if we timed them perfectly, before would happen early, then some time would pass for the function to run. Then on return, promise resolve would happen. And after that, almost right away, the after hook is happening. So if you see, they're generating a lot of unnecessary output, really. So we're not going to use all of them, definitely, not to repeat ourselves too much. Instead, I want to talk about the destroy one. So if we were running an actual application that does a lot of things, and we would keep pushing stuff to this map, we would run out of memory. So this diagnostic tool was in fact a memory leak. I hope I'll get to the memory leak topic by the end of this workshop. But to prevent that from happening, we just need to clean up. So whenever we get a destroy on async ID, we just remove it from our collection. There's a lot of other things you could do for this purpose. Like you could use weak map, for example. Some of the implementations of async hooks tools I've seen use that. But this is the most obvious thing to show the purpose of destroy hook, right? And I'm actually using that a lot wherever I'm using async hooks. So recommended. Although destroy is a bit expensive. So if you set the destroy hook, there's a bit more work that needs to happen when things get cleaned up. So definitely don't put stuff in there, right? Okay, now the before hook is also interesting. And here I'm starting to introduce a new concept. So let's switch to the presentation for a second. And let me tell you about it. Okay, so Node.js has a thing called performance trace. Okay, in general, there's trace events. You can use various trace events, but then there's perf tracing. And performance hooks are also a thing. So we can use performance hook. We get this handy little tool. And this one's much better than console time because it has much better output methods. So there's performance.mark. You give it one ID. There's another performance.mark a bit later. And then performance.measure, you give it a bit of description. And then those 2 IDs that you want to measure the difference. And now, if you run Node with trace event categories set to node.perf, it's going to produce a trace log containing all your measurements. This is a file that's not very human readable, so it's not a log like you think of logs from an application. This is a log that's usable for something else, and we're going to see that in a moment. Okay, yeah. So I'll get there in a moment, but now, see, on before, I'm marking the moment when it happens, and then let me write a bit more code here. I'm also marking the moment when the function finished, and then measuring it. So there's all the identification info that we're also printing to the output, but then I have the before and after passed into measure, and this is going to produce a nice log file. Let's run it. Okay, nothing changed, but if you look carefully, there's node trace.1.log in my current folder. So what do I do about it, right? Well, we need a tool to open it. And since Node is using V8 and tracing is coming from V8, we use Chrome for that. So we go here and type about tracing. That's what it used to be called. Now it's Chrome tracing. Okay. And this interface is a bit dated, but this is a development tool. Let's say we load it. Okay, so we load the file. It reads our stuff, and now you can already see this is somewhat interesting because we have a visualization of what happened in our application in time. So there's two blocks that you should be able to associate with what's happening already. So this big one is coming from line 18. Let's look at the line 18 and the minimal example. Line 18 is this. So the asynchronous resource here was the one wrapping this promise for a slow synchronous function. And 100 times 1 is 100 milliseconds. This is how long that function took. And the measurement is close to that. So bear in mind, async hooks, if you use measurements there, are not going to be perfectly aligned with the time you spend in the function because there's stuff happening around it. But they're very close to the actual measurement of what happened there. They're actually just measuring a bit too much for our purpose to be precise, but they're very good for this measurement because the resolution is definitely enough. We can see that this is a slow function, and we can see that this function is twice as slow. Okay? So if we want to explore this a bit more, there's this bit of interface I'm moving around here. And now these are 4 functions we can use in this UI. And they're not easy to use, bear with me. But yeah, there's this pointer thing. That's just for selecting stuff. This one's for moving it around, and this one's the most useful. It's for zooming. But if I want to zoom, I need to click and drag down to zoom out, app to zoom in. I'm going to zoom in and then switch to this one to move around. So we can take a look at some other details. Okay, so this is our code. See, this didn't take a lot, and this one either. So we know what how long it was, and it's line 17. Let's look at line 17 real quick. It's this function, plus the whole time spent wrapping it in a promise and all the fluff around it. Okay. I hope this is exciting to you as it was exciting to me when I first did it. So with this match code, like just take a look. Like it's 57 lines minus some spacing. We produced a tool that can measure the time it takes for your functions to run, and it can visualize it so that you can explore it. It's not perfect, definitely, but let's work a bit on improving it. First off, if you notice, these items here are not ordered correctly because they start with the number 10 and 13 and then go down to 3. Why? Because this is in alphabetical order. So let's exploit that fact and just pad the numbers. So remember left pad? This is a running joke, so I hope some of you remember it. Yeah, I didn't import it. I just wrote the most naive version possible, and I love it. No dependencies here. Okay. So we measured it, we padded it. It's going to look much better when we now run it and load it. Let's do that real quick. I don't want to take too much time doing this again. Okay, now they're in order. Looking nice. Everything's in order, and we can see that these functions, the short functions happened here, and then they happened one by one, and then the long ones were scheduled one after another because they're blocking, so event loop couldn't do them both at the same time, right? Okay, back to our lovely tool. So if we can see it with our own eyes, why don't we get the code to detect a slow function, right? We already have everything we needed to know. So I'm going to take time measurements and put them on my data object. So I'm taking the current timestamp, and then after the function runs, I'm also taking the current timestamp. And if anyone wants to tell me date now is not good for that, I know, give me a second. And then if the difference is more than 100, it means we detected a very slow function, and we can print a message about it telling us that there's a function like that. Okay, I'm going to run it now. And as you can see, it says slowness detected at this place. Clicking, there we go. This is the place where the slow function is being put in a promise. So if you remember talks, even from this conference, there was one talk on Tuesday, which was about some monitoring and stuff. I mentioned that there's tools for detecting event loop being blocked, but they don't point to a place where the blocking happens. Well, this one does. If you want to rush and publish a package to NPM that does this for people, too late, I already did this. It's called blocked at. Feel free to use it and report stuff, because there's a lot of work involved in eliminating false positives and interesting stuff happening there. So it's not as simple as you're seeing here, but it's fairly close. Okay. Now, if we want to detect something, or if we want to do some sort of timing, we need to learn one more thing. Date now is not good enough. It's not seeded fast enough. So we have functions for that. There's a function, I called it high resolution time, 2 milliseconds. This is my little helper that takes high resolution time from the process. This is time that's reported in nanoseconds or even microseconds, depending on how you read it, etc. And then this is the lovely line that's necessary to convert it into milliseconds. But there's nothing more precise than this. This is used in all the benchmarks and so on. It's not going to change anything drastically, so I'm not going to run the whole thing again because we have half an hour left and there's plenty of stuff I still want to cover. So let's move on. So we have perf tracing incorporated already. We had async hooks. Now the question is, should you really use async hooks, like for real? Well, it's complicated. So the fourth argument to init is a reference to the asynchronous resource itself. And this is internal to Node.js, and this can change even between Node patch versions. So you shouldn't rely on it. Like just forget it's there. You'll be fine. There's a thread in Node.js collaborators on GitHub discussing what to leave and what to remove, and this resource reference is the first thing that everyone agrees should be removed from the official API. So yeah, async hooks are still experimental. So it's not wise to put them in your code that you intend to maintain for a long time and don't put a lot of work in it. And they have a bit of a performance impact depending on how much you use them. The bigger performance impact is coming from your code that you put in them. So obviously, when your code does a lot, every time a hook is called, it's going to be costly. That's why in this implementation, if you notice, I'm checking the data, and if there's no data, so I decided to ignore it when the init hook happened, I'm not running anything else. This is step one. Step two is not using unnecessary hooks. So make sure that you only use the ones that are necessary for your application. Okay. At the same time, they're great. They've been with Node since 11 point something. They got the first major release in Node 12, and I've been using them ever since, and everything seems to be working still just fine. And async hooks are making some great things possible. So if you do have a use for async hooks, sure, use them. Use them for tools, use them for learning how things work under the hood, for debugging your applications, and building great stuff. Don't run them in production by default. No, there's no point. How about other uses of async hooks? Well, async local storage was covered in one of the presentations on this conference as well, so I'm not going to get into too much detail. But this is an actual production feature that is good enough for you to use already. There's talks of pulling it out of the experimental and stabilizing it, etc. And this is built on top of async hooks, but it might at some point, without any changes to its API, be converted to something more level or implemented directly into core. Anyway, this is great. And if you didn't watch the presentation, I recommend you look at the presentation about async local storage and its uses. You will definitely use that soon. Like in a year or two from now, most reasonable libraries or frameworks for doing HTTP stuff, servers, are going to use it for keeping context or having access to logger, etc. Some of them use that already, and it's really great. It improves the experience of writing Node.js servers a lot. And do use perf tracing. It's great. It's not necessary to produce the log file. You can read the measurements inside of your application and pass them over to any sort of monitoring you want using Performance Observer. So it's coming from the same internal package, perfhooks, and you take Performance Observer, you create a new instance of that, and you tell it what to observe. And if you choose entry types to be measure, you're going to get a list of entries every now and then, and you can then pass them over to whatever you need, really. You can send them to your monitoring tools, and that's possibly the nicest way to measure how much things take in your application without installing a costly APM. Okay, so now a short look at the entry types. Obviously, the measure one is the most useful. Out of those, most generally useful. Then mark can also be listened to, so we can just mark things without doing the measurements. And you're going to get the time of the mark. Maybe that's useful for something. And then there's a few things that Node itself reports. So we can put HTTP as entry type, and you're going to get a measurement of how long it took to handle an HTTP request every time one happens. And there's a few others. Do check them out if they seem interesting. But we're not here to learn stuff from a presentation, right? So let's see how we can abuse this API to build something else, something that's possibly useful for diagnostics, and something that's going to make some people say, no, that couldn't be possible. All right. So the next step, this is how Performance Observer generally gets introduced into your code. So we have the Performance Observer, and then we get the entries and everything. So I can just run it. Oops. I can just run it and take a look at what's going to happen. So I'm going to choose to run it on a different sample. So one of the samples I have is a server. And it's a funny little server that I made specifically for this. So there's an HTTP server that does what you already know from our first minimal example, just to take some time. But then when we start listening on that server, I put some silliness in here. So the process is calling itself, and then when we respond, it's just closing the server. So this app can be run. It's going to make one request to itself and then finish. And when I run this with our new diagnostic tool on, it's going to print whatever came to the input. Where is it? It's here. List get entries got printed out, and it says HTTP request timing, entry type, HTTP, duration, and start time. These are, again, low resolution. So these are very precise. And you can measure anything with that, but HTTP is very convenient. So Node is telling you exactly what it took without you instrumenting your application in any way. As you saw, I didn't put any specific code in the application itself. I'm just adding, again, a command line require. I could as well require this as a first line of my application. Would work the same. And I'm measuring stuff. Okay, but as useful as it is, it's not crazy. It doesn't seem impossible, and that's not what we're here to do. So let's look at another thing. So I don't know if you know, but you can access V8 from Node. to get some useful information. One of those is a function called get heap space statistics. And it's just telling you how much memory is occupied. Okay, so let me run this now. What are we getting? We're getting a bunch of spaces. So it says read-only space, new space, old space, and it gives you the size, the used size, a lot of stats. Okay, you probably don't know what are those spaces. So let me look at the timer. Okay, I'm gonna quickly jump into a talk I gave about it a while back. Okay, some history. No, garbage collection. Okay, so check it out. JavaScript has garbage collection. So see, you can allocate stuff, and then when it comes time to clean it up, JavaScript is garbage collected by copying stuff that's still useful and reachable, and then swapping the spaces and discarding everything else. This is outdated. So there's a lot of work that went into the garbage collection. There's incremental garbage collection, generational garbage collection. Some of them were first introduced in Firefox, but generally stuff gets introduced everywhere. And the interesting part is the generations. So we have two generations, young and old generation, and the cleanup and swap is happening here. And young generation is stuff that is newly created, or it survived one garbage collection. Old generation is everything that survived more than two garbage collections. Okay, that should be enough to understand what's happening here. So let's ignore all the other spaces, but we have the new space, we have the old space. There's a place where our compiled code is stored, source maps, and large object space is also interesting. Okay, let's start building something. So check it out. We now have a performance observer, and we're choosing the garbage collector entries and saying we don't want it buffered. What does it mean? Performance observer's callback is going to be called every time a garbage collection entry shows up, which means after each garbage collection, we're going to get a callback. Well, isn't it convenient? So if we check the heap space statistics after each garbage collection, we know that it's only the memory that's currently used by our application. So we don't get random increases in memory that are going to get cleared out in a moment. So this becomes very useful information. We can print out heap information and start looking at it to see if any of the spaces is constantly growing, because constantly growing means there's a leak, right? So this can warn you about memory leaks automatically from within your process. Sounds interesting. Let's go through a few iterations. So I get the statistics, I can filter them out and just take the interesting ones and then print them. So let's do just that. I'm going to take another sample, and this one is leaking very slowly. As you can see, it doesn't garbage collect very often, but the old space keeps growing and growing and growing, while other spaces behave differently. So the large object space is not growing, and new space is fluctuating. So new space just went down a lot, so everything got cleared out from the new space and went into old space again. So see, it keeps growing. Garbage collection is very complicated. As you saw some links in my presentation, this is a tip of the iceberg. There's different kinds of garbage collection happening behind the scenes. So there's going to be some fluctuations here anyway, but we're getting pretty solid data. Moving on, I can take the previous values for some spaces and read the new values and then accumulate them. Let's take a look at this code. I don't want it to sound too complicated. So here we have the statistics. We're filtering them out, and then this reduce thing is here to produce something like this. Okay, and then we're assigning the current one to the previous one. So all this code here is to produce an object like this with values in those fields for the space used size. Okay, as you can see, it's not printing anything, so let's add that. We have a console log that goes over the current values and prints them out as an absolute difference. So it's going to print 1 for growing, -1 for shrinking sizes. I'm going to run it again now. See? Growing, growing, not a number. Growing, growing, shrinking. New space is shrinking for a moment, and then stuff keeps growing. Okay, we don't like this not a number thing. It doesn't look professional, so let's just add one little fix. See this thing here? Yeah. So division by 0 produces the none. We don't like that. Now we got 0 if it's not changing. So large object space is not changing because the sample is not really producing large objects. Okay, that's fine, but do we want to look at it? It's like looking at a chart growing. Growing chart is much more useful than this. So maybe instead we could detect the leak automatically. Let's do that. So I cleaned out a lot. So there's previous and there's total. Here I'm aggregating and removing the new space because new space is not really capable of leaking. And then we're iterating on the current information, checking if it's larger than previous. And then we're incrementing the total. So this logic says if something was growing, then keep incrementing. If it's stopped growing, it's now shrinking or staying the same, reset the total. And now if total is larger than 5 or equal, we detected a leak. So this part says if we had 5 garbage collections and the space kept growing throughout those 5 garbage collections, we seem to have a leak. Check this out. This is the process that's leaking. It's doing a lot of spammy things, but it has one array, and it keeps pushing to that array in an interval. And this bit is a bit of spam to get garbage collected. Okay? So we have a leak detector. Let's run it and see if it detects any leaks. Waiting, waiting, waiting. Some waiting involved. Okay, nice. Don't worry about the map space too much. But a leak in an old space is very interesting because it's necessarily caused by your application's execution. Yeah, we detected a leak. Okay. The server is also leaking, so if you want to have some more fun, with it, you can remove this part and make some requests to the server, and the server is going to leak to this place. And you can start detecting it and have some fun with it. Okay. So going back to my original presentation. Okay, V8 bindings, there's this binding that we used, but there's other bindings that are also interesting. So we can get a heap snapshot. And this is returning a stream that you can send in a response. So your server can have an endpoint and make sure it's secure, because no one else should be able to access it. But you can have a maintenance endpoint where you make a request and you get a heap snapshot back. Warning, producing a heap snapshot takes additional memory. So if you're running low on RAM and you want to diagnose it and you produce a heap snapshot, it's possible to crash your application. Then you can get heap statistics. This is the one that we used. Setting flags is also fun. So if you have any V8 flags that you want to set, you don't need to pass them to the node command itself. You can implement getting them from somewhere or switching them on and off. Some interesting stuff. And you can also write a heap snapshot. And this is going to produce a file name with a heap snapshot. And you can look at some older stuff I did, try to find it on YouTube somewhere, or listen to anyone else, because this didn't really change since 2008. But if you get a heap snapshot, or preferably two, you can take them, put them in developer tools, compare them, and find what's leaking. Warning, very difficult. Okay, so that's about it. I'm going to now open up for questions. We don't need to finish on time, so I'm going to stay a few more minutes with you. This has been building your own diagnostic tools, and I hope you learned something, or at least had fun. Thanks. Opening up for questions. Feel free to type in chat, and we can even start opening the mics when that feels more convenient. Let's start with chat in case there's a lot of questions. Okay, typing away. Meanwhile, I can entertain you a little with the explanation how this live coding works. So what I'm doing here is I have commits in history, one by one. And if I want to show the next step, I check out the current state of the next step, and then reset to a situation before it, so that Git thinks it's one commit back, but the content from the next commit stays. And that's how I get the highlights for what changed. And these are two commands. This is the Git part. And then this is making a sound, so I know it succeeded. And this is opening the next one. And I also have a task implementation for VS Code, so I could open it from the VS Code commands. And then if you have these as tasks, you can also set shortcuts. So that's what I did, and that's how this works. So instead of typing the whole thing, I can press a shortcut to move backwards and have that step, or move forward, have the next one. Okay, I'm not seeing anything in the chat, so feel free to unmute your microphones if you want to say anything. We can now go wild. this has officially ended. Let's hang out. It's a conference. You want to chat? I'm going to stop sharing. Hope you liked it. Yeah, you can use this trick. I don't think I updated everything, but it's posted as a repository, Git coding, Git live coding, something like that, on my GitHub. And the core functionality is there. And if you want to use more, you can actually rip it off of this repository, because here I'm gonna, oh wait, now I don't see the chat. Okay, there's some more tricks involved here. I can show you. So there's a dev branch, yeah. And in that branch, I also have a script called create history and a folder called history. So I have all the steps here, loosely numbered, with commit messages for each. And then I have this messy script that goes through everything and creates an entire history. So feel free to do your own live codings with one keypress. I would love for you to do so. This is all openly licensed and ready for you to use. Okay. Yeah. Take care. Thanks. All right. So if you want to find me, look for Nauctor. My name is also gonna pop up some useful stuff. Look for me on the web and find my earlier work. There's a lot of recordings you can learn from. And I love diagnostics and memory stuff. So whenever you have questions, feel free to reach out. I can help you out or consult on stuff. Yeah. Let's keep the community going.